Hi, we're students at Dunseith Indian Day School here at the Turtle Mountain Reservation in North Dakota. Yay!
In ancient America, our ancestors dreamt of flight, and we celebrate this dream through our dancers and stories, because American Indians have always been fascinated by the flight of the powerful eagle and the graceful butterfly.
NASA Connect asked Dunseith Indian Day School to show you this program's hands-on activity.
You can download a lesson guide and a list of materials from the NASA Connect website.
Here are the main objectives.
Students will predict the effect of kite sail area on kite flight, measure the base and height of a kite, use reflections to create kites, calculate area of a trapezoid, calculate aspect ratio, understand how early flight was influenced by kites.
Here are some terms you'll need to know.
The span of a kite is the widest distance from side to side. Aspect ratio is the ratio of the square of the span to the area of the kite. Drag is a force that pushes against an object and slows it down. Lift is the aerodynamic force that holds an airplane in the air.
Good morning, class. Today NASA has asked us to investigate the size of kite sails to determine how area and aspect ratio influence flight efficiency.
3 kites will be built using different measurements as outlined in the lesson guide. First, hold the long end of a piece of 8.5 by 11 sheet of paper and fold it in half. Starting at the fold, measure 3.5 centimeters along the top of the paper and mark point A. Now measure 9 centimeters along the bottom of the paper, measuring from the fold. Mark point B. Draw a line segment AB. Reflect line segment AB across the fold line. Call the reflection of point A, A prime, and the reflection of point B, B prime. Draw a line segment A prime, B prime. Fold back along line segments AB and line A prime, B prime, forming the kite shape. Place a piece of tape firmly where line segment AB and A prime, B prime meet. Place a skewer stick along the span of the kite and tape down firmly along the entire length of the skewer stick. Cut off any excess. Tape a kite tail to the bottom of the kite sail where point B meets point B prime. Starting at the top of the flap, which is labeled point F, measure 7 centimeters down along the flap and 1 centimeter in from the fold. Mark and label point E, then punch a hole at point E. All measurements will be recorded onto the worksheet. You will calculate and record the kite sail area using the given formula. Area equals 1/2 the height times the sum of B sub 1 and B sub 2, where H is the height and B sub 1 and B sub 2 are the bases. Remember to multiply the value by 2 to calculate the sail area. You will also calculate and record the aspect ratio using the formula AR equals S squared divided by A, where S is the kite span and A is the kite sail area. Tie one end of the string to the hole and wind the other end onto a cardboard string winder. For the other 2 kites, repeat the same steps, adjusting the given values for point A and point B found in the educator's guide. Remember your reflection. Once you have completed your calculations, it is time to proceed to the outdoor test flight.
Teams, are you ready? Let's let them fly!
Yay!
Perform 2 trials for each kite, rotating student roles until all 3 kites have completed their 2 trials.
There are 2 questions that we need to answer. How did the surface of the kite affect its flight? And was this effect significant?
Roger?
The smaller kite didn't have enough space here, surface area. This flew just right, had enough surface area. This did too much acrobatic.
What other factors could be changed to investigate the effect on kite flight?
Josh?
Weather, wind, tail, surface area, and weight.
When you complete this activity, discuss what improvements you would make to your design. A helpful tool is the interactive kite modeler from NASA Glenn Research Center. On this website, you can study the physics and math which describe the flight of a kite. You can choose from several types of kites and change the shape, size, and materials to produce your own design. By selecting the Field button, the kite flies with the control line running from you to the kite. Depending upon your choice, different variables are shown. The values of these variables are shown on the output panel. The kite modeler tells you if your design is stable or not, and also computes a prediction of how high your kite will fly. Teachers, if you would like help to perform the preceding kite building lesson, simply enlist the help of an AIAA mentor, who will be glad to assist your class in these activities. AIAA stands for the American Institute of Aeronautics and Astronautics.